Hi, everyone. Welcome to the International Methods Colloquium. I'm Justin Essery from Rice University. The International Methods Colloquium, or IMC, is a periodic online interactive seminar discussion on the application of quantitative statistical methodology to the social sciences, sponsored by Rice University and the National Science Foundation. And you can see we're doing a special joint event with Rice University's IR working group today, so there will be a live studio audience to provide a laugh track or whatever might be needed for the talk. This week's speaker is Phil Schrodt of Parus Analytics. His talk is entitled Current Developments in Event Data. Phil's talk is going to last between 30 and 40 minutes, after which point we'll take questions from the audience, both live and remote. If you are watching on the internet, you can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window, and I will see that and read it out. A link to Phil's slideshow will be available in the Zoom webinar chat window, so that you can refer to it throughout the presentation, and I will post that link right after I get done with this introduction. And now I'd like to welcome Phil Schrodt to the IMC. Phil, welcome.
Thank you. So just a general introduction to what I'm going to be doing today. The emphasis here is going to be on the practical side of using event data, and I'm going to be focusing on a lot of stuff that has really come online quite recently. In fact, some of it's still in the process of coming online. If I was going to give this presentation in 2 months, I'd have more than I have now, but better to do it now than never. I've got a lot of slides here, but as Justin just said, they're available on the web. I'm not going to read through all of my slides. In fact, some of them I will skip over pretty quickly, but you can either go back and look at them, or you can decide you understood enough without looking at them. So let's get going. First, I assume most of you watching have a general idea what event data is, but I am going to go into a little more detail here. But why all the excitement? Why is there a lot going on right now in terms of event data? And there's quite a lot, both in the academic side and certainly on the government side. And I think the excitement is that we have, with event data, the fact that we now have the ability to do fully automated coding, and if we're trying to do, say, predictive models, which a lot of this work is done with, the same with the models, we can do this stuff to give ourselves, in a sense, instrumentation that is monitoring all of the political events, or all the political events that we're interested in real time. And this is due to the combination of the automated coding and the fact that you have pretty much all news feeds now are available on the web. So as I say, there's quite a bit of excitement about this stuff and a huge amount of work. The other thing that I guess is happening, and this is going to be a theme running through this whole presentation, is we now have the ability to leverage a whole bunch of stuff that's going on elsewhere, open source software, particularly in computational linguistics. So whereas event data started almost 50 years ago, in fact, more than 50 years ago, we're really in a position now where we can do a lot of stuff that we couldn't do before. So, as I said, event data started in the 1960s, work of Charles McClellan and Ed Azar. The first 20 or so years were mostly human coding, which simply couldn't keep up. People wanted to do crisis forecasting, but if you're going to do crisis forecasting, you've got to have data that's more or less in real time. And the human efforts just weren't able to keep up with that, even at fairly high levels. In the 1990s, though, we had some collaborations that produced the first automated coder, and the automated coding systems, of course, can keep up in real time. And we also extended from international focus on international events to a lot of stuff on sub-state events. So I'll be mostly focusing on international here. By the beginning of this century, we had a couple of new coding, sort of the second generation of coding systems come in. And then late in the 2000s, we got a very large project called ICEWS, Integrated Conflict Early Warning System, sponsored by DARPA, the Defense Advanced Research Projects Agency. And ICEWS invested a huge amount of money in this. It was tens of millions of dollars, probably somewhere between $40 and $50 million. And this ends up producing the best data set that we have available at the moment. But things haven't stopped there. I'll be talking a lot about ICEWS. We're, again, continuing to see developments in computational linguistics and in tools that we can use. And so we're getting more coders available. And I'm going to be talking a lot both about the data sets, but also about the various coding systems that are available. And actually, I will finish by suggesting maybe you want to write your own coder. So the technological changes, again, these are, I've pretty much gone over this, but we've been able to take advantage of the fact that over the last 30 years, there have been huge advances in software, in particular open source software, but also more general knowledge resources. So geonames.org, which is used for geolocation, Wikipedia, which more times than not is really a useful source, are all available to us, as well as these news sources. The other thing we're finding about event data is that it's particularly well suited for predicting political change. And this, as I said in the earlier slide, this has been the focus from the very beginning in event data. And what we found is that while structural indicators are quite good, they change very slowly. So things like GDP and for mortality rarely change more than a couple percentage points or a few percentage points per year. Social media indicators, which people had a lot of, were quite optimistic about, change too quickly. So they give you, if you're really short time frame, those are good. But what people were hoping is these social media indicators would provide some sort of deep structural or cultural signal. And so far, nobody's figured out how to do this. It's just too much. Just, hey, want to go get a pizza type stuff. And then, of course, we now also see these, we're seeing big time, these things are being manipulated, particularly by authoritarian regimes. So they're not a reliable source. So these news events that we use in event data seem to be just right. And what we're finding is that they are, a number of these projects, they are turning out to be quite useful for these types of models. Now, a warning, sort of, this is one of the two trigger warnings in the thing. If you look at this stuff on a case-by-case basis, you will be appalled. And this is a problem of getting the stuff used, because these are imperfect systems, they're fully automated, and people start going through and say, that's wrong, blah, blah, blah. But you got to look at this stuff as data, or really big data, which is to say that statistical and machine learning systems can do very well with it. And in fact, we found it's just as good in predicting conflict events, for example, as the structural indicators. But it's big data, and it's going to have noise. You'll see a lot of that. And it's not perfect, but it seems to be good enough. The other thing I would say is that I think we and I wrote about this earlier, way overestimated how accurate the human coding is. We claim that it's 80%. It's probably considerably less than that. But the bottom line is, if we're going to do real-time coding, you got to use automated coding. So it's more a case of saying, let's see what we can do with this, data that is not perfect, but seems to be good enough, because this is the only way we're going to keep up with the real-time coding. So let's just quickly, for those of you who haven't seen event data before, I'm going to go through a quick example so you've got some idea of what I'm talking about here if you're not familiar. What a news story, what event data will do is it'll take a news story, and we typically code the first 6 sentences, but it'll pick up this lead sentence here. And what we're trying to look at, or what we want to pick up, is who did what to whom. And so in this particular case, the first thing we pick up is the what happened, which in this case is criticized, which in the Weiss event ontology has an event code of 111. We want to figure out who is doing to whom. So this is Iraq is criticizing Turkey. And then in a modern event data set, what we also want to do is we want to pick up what we call the agents, or the substate actor. So this is Iraqi leaders are criticizing. And then finally, there's actually 2 events here, or we can pick up 2 events. There's a second one involving Turkey is bombing Kurdish militants. So we can see we're also picking up bombing as the second event, and again, Kurdish militants. So basically multiply this by, whatever the size of your data set is, 25 million stories, whatever, and this is what event data ends up looking like. We've had a number of different ontologies or event data coding schemes over the years. I won't go into these in detail except simply to point out this stuff goes way back. The one that is currently in use for the most part is one called Cameo. And the currently available data sets are all based on, are all coded into Cameo, which Deborah Gerner and I developed, and Umar Yilmaz developed in the early 2000s. It was a modification of Weiss, which I'll show in a second. The new development, very new, just in the last 6 months, 6 months, maybe more like 4, is we're working on a new system called PLOVER, which I'll talk about in some detail later on. But most of the stuff at the moment is Cameo. All of these systems come up with relatively similar numbers for what you need. It turns out you need probably about 15,000 or so phrases to describe the types of political behaviors we're interested in. These and almost all of these systems get it coded down between 50 and 200 mid-level categories or micro-level, and about 10 to 20 macro-level. And here's the example from Weiss, which really is still the basis of all of these. And you can see the ones on the left are pretty much cooperative events, the ones on the right pretty much conflictual. And this Weiss scheme, though it's been modified in Cameo, we're modifying it some more in Plover, is still pretty much the overall framework that is being used in these things. So this is the level of detail we're looking at. Cameo, I won't go into this in a lot of detail because there's plenty of stuff on the web, including 2 different manuals on Cameo. But basically, we started with Weiss. We combined some ambiguous categories like warnings and threatens, and then we tried to standardize some stuff. So we switched, for example, to the ISO 3166 standard for the country codes. And following the PANDA project, Doug Bond's project at Harvard, we systematized some sub-state actors like government, military, REB is non-state militarized actors, BUS is business, ELI is elites, and so forth. We also incorporated NGOs and IGOs into that, and we've got a bunch of dictionaries implementing these, both in our project, and then ICEWS, which is available on Dataverse, also has very extensive dictionaries available. This quad counts I've just put up here to indicate the next couple of graphs, but a lot of times this is broken down into just 4 categories, whether it's verbal or material, whether it's cooperation or conflict. And the sort of data you get, this is Levant data set, which actually runs to 2015 now. And this is the sort of scheme. This stuff is noisy. All event data is noisy. But you can see, for example, down here, the second Palestinian Intifada, much smaller. The first one, you can see points at which this is the Oslo process, where people were talking a lot. Here's another visualization of that Jay Yonamini did. Similar, there's lots of different ways to do this. I'll get back to why a political science PhD is head of data science for global patents at Google later in the talk. Here's another set of indicators. I literally did this 2 days ago. We were trying to come up with some indicators of regional tension. This is based on IQs. You can see, for example, here's the Ukraine crisis in Europe. Middle East and North Africa is always kind of crazy. Central America, again, this is just international stuff, not domestic, is always pretty calm. So this is the sort of stuff, and again, the sort of noisy, but nonetheless, definitely there signal that you get out of event data. The way this is generated is you start out with your ontology, whether it's Weiss or Cameo or Plover or IDEA or any of these others. You derive noun and verb dictionaries, phrase dictionaries to implement this, both the types of events that you're trying to deal with and the actors that you're dealing with. So Kurdish militants would be an example of an actor. We'll see a bunch more. You download your news stories. You can get these from an aggregator like Factiva or LexisNexis. You can get them through RSS feeds. You can go to websites, a whole bunch of different ways to get these now. And then you feed this into an automated coding program, of which there are several available now. If you're doing forecasting, then you have this additional thing down, this additional set of things down in the lower right corner where you develop your model and you make your predictions. And again, most of these are being done for either monitoring or forecasting, so you end up with your predictions, your events of interest. In the contemporary world, we also have several other steps. It turns out that filters are really important so you don't end up coding war movies as wars, or particularly sports stories. Sports writers love to use military metaphors. Nowadays, we typically, at least most of the systems that we have now use an external parser. Stanford Core NLP, which I'll talk about briefly, is the most popular one pretty much for everybody. We should be clustering stories. We're not. Instead, we use this thing called one-a-day filtering, which again, I've got a discussion of earlier. And then finally, geolocation. And as I mentioned in the abstract, I'll talk briefly about a program Antti Halterman did called Mordecai that does this. And you basically connect all these things using what you would call a pipeline or a glue program or whatever. You basically string them all together. And this is, news stories go in at the beginning and coded event data comes out at the end. Stanford Core NLP, this is, I'm trusting that most people watching this know how to use Google, so I don't have the address on here, but this is their homepage, is a whole bunch of tools for natural language processing, NLP. And this is pretty much emerged as the standard that most people are using. Particularly the parser is mostly what we're using. Though I would draw your attention to a new system that's getting a lot of use called Spacey, that does a lot of the same things that Core NLP does. As you can see, they definitely have a following in the commercial sector. What's cool about Spacey is it's designed as a practical system. It does the stuff you want very easily. So just for example, this is the program I've written. I'll get it on to GitHub pretty soon. I was just basically developing a simple support vector machine filter, and this function down, this is Python if you don't recognize it, get words, does basically everything you need to do to the story, and basically Spacey is doing all the work. You basically tell Spacey to break this thing up, standardize it, blah, 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 and then to just get the words that you're interested in is just literally a single conditional. So Spacey and other things really do, and this is a good example of how, and it's open source, you just download it, it works the first time, etc. It's got a really nice support community. This is a really good example of how, with these modern tools, things are so much easier than they once were. Because to write your own code, to do all this stuff, you're talking pages and pages of code. And here, you're just talking lines and a single conditional. Okay, just quickly, here are some more resources. Deborah Gerner and I wrote a kind of a book on this quite a few years ago that I then updated, papers, blah, 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 blogs. Okay, ICEWS. ICEWS, as I say, was a very large project. Probably by now has spent something like $40 to $50 million. The original one was 35 or 40, something like that. And it went through a research phase, an operational phase. It was originally focusing on Asia. They initially used the Tabari coder, which I wrote, and then they moved it into what was actually a very nice coder called Jabari that's kind of disappeared. It's coded into Cameo. They used Factiva as the aggregator. The data were very similar to what the the objectives were very similar to the Political Instability Task Force. In fact, as a taxpayer, I might argue a little too similar, but they got similar results, about 80% forecasting accuracy. IQs moved on to an operational phase that's been going on for about 5 years now. And they shifted from Jabari into a coder developed mostly by Liz Borshi at DBN, started out bought by Raytheon, called Accent or Serif Accent. They've now shifted to global coverage. There's still a bit of an Asia bias in the data, which you should be aware of. I mean, I've got a paper somewhere on the web. There's more events at the moment coming out of Asia than you would expect. So I think that Asian original origins of IQs in Asia are still having an effect. But the key thing is that about a year and a half ago, all this data with a 1-year embargo was released on Dataverse. So just Google IQs on Dataverse and you get the data. It's a huge amount of data. 1996 to the present, as I say, with that 1-year embargo, it's updated monthly. Been very reliable at doing that. They also did a much more extensive refining of the Cameo specification. And again, that's on the manuals on the on Dataverse. Liz and her team, she had several people working on this, and they did a lot of human validation. So they really did do a lot of work there. And it's got the actor dictionaries. It doesn't have the verb dictionaries because they're built into the program, though you now can actually license the program. And I say geolocated with a few errors. All geolocation has quite a few errors. I think Mordecai is better, but there is some geolocation there. It's mostly to capital cities, but it's a start. But anyway, IQs is far and away your best data set, and it's covering what almost fully 20 years now of data. The one downside of IQs is it's kind of a quirky format. It was for various reasons. It's a textual format. So instead of using codes, they actually give the full description of the Cameo category. So I wrote a little program called Text to Cameo that converts it to a more conventional thing. So you probably would want to run this thing through. You can see this is the original format, and these aren't this. I couldn't find the actual events there, but it'll convert it to something more conventional. Even give you cow codes for it, but these are your more conventional ISO codes. So you probably want to run your Cameo data, or sorry, your IQ's data through this thing before you do the statistical analysis. But it's just, it runs, it's reliable, etc. Okay, the problem, however, for some of us is that IQs is embargoed for a year. And so if you're looking for real-time data, IQs is not your solution. So this and a number of things were what motivated us to start the Open Event Data Alliance. And we're trying to do with the Open Event Data Alliance, which is my other hat beyond Parus Analytics, is we're trying to set up a data model, collaborative research thing, which it turns out are incredibly common in the world. In fact, it's kind of amazing we didn't do this before. And so we're producing both software. I'll be showing you a lot of Open Event Data Alliance software, and or where you can get it, and also trying to produce a near real-time data set. So that's the Open Event Data Alliance. Our first effort was something called El Diablo, which was basically to provide an open source, everything in the Open Event Data Alliance is open source, to try to find, provide an open source solution for generating real-time data. We got this cool logo from that Josh Stevens at Penn State, or at Penn State at the time, did. It's been replaced by a system called Phoenix, mostly John Beeler and Andy Halterman's work, with some other contributions from Keras Associates. But again, this is all open source. If you want to set up your own near real-time system, this is, you can just download Phoenix, get it installed, and it should run. I would like to say that it has been completely reliable, probably in anticipation of this talk. The stress identifier in the system identified that I wanted to be able to say it's completely reliable. So we've had some problems over the last month, and it's actually dropped a few days. We've actually got backups for this, but in general, it's been running pretty much continuously for over 2 years now, or yeah, over 2.5 years. Two different coders out of this, Petrarch 1, which was the original Python version, essentially, of Tabari that made our original use of the core NLP parses, though it was basically mostly using this for parts of speech identification. We also did a bunch of, again, standardization. We put in a bunch of synonym sets from WordNet, again, another natural language processing resource out there. But it was still kind of halfway between Tabari and the more recent version called Petrarch 2, which basically uses the full information out of the parse. So these are two coders. They're actually quite different. They have the same name, but they're really substantially different efforts. Another thing that's going on, I'm going to go through this part pretty quickly, even though I'm involved with the project, is NSF about 1.5 years ago put a major investment into event data, almost $2 million in funding, which for NSF, those of you who are familiar, is a lot of money for a social science type program. Lead institution is UT Dallas. Patrick Brandt is the head PI. So a number of other institutions involved. And it's both political science and computer science. And as you would expect, it's generating data sets. So the key one is one that's coming known as Terrier, which will be coding all of the material in LexisNexis. They've got it downloaded. It should be there available fairly soon. The other major focus is going to be doing multi-language coder using what's called a universal dependency parse, which I'll talk about a little bit later. But they hope to have a coder that will work in English, Spanish, and Arabic. Lots of progress on this. Pretty much translated the Cameo dictionaries already into Spanish and Arabic. So we should be able to do native language coding on this, possibly extending it. So where you are right now in terms of the data sets is you've got IQs, again, far and away your best. For near real time, particularly if we can get it a little more stable, you've got Phoenix. This Terrier data set should be available fairly soon, probably next couple of months. And then finally, this is going to be available, just found out about this, or I knew it was around, I didn't know how far they were. The Klein Center at the University of Illinois is going to be releasing a data set with some very long time series, particularly New York Times back to 1945. We've never had event data going back that far. And even the 1980 ones are much longer, IQs only goes back to 96, so almost doubling things. So that again should be available. I assume it will be announced at the usual on the usual listservs. So I'm now moving to new stuff. Again, I'm not going to read this entire slide, but the problem with Cameo is it's a very elaborate system. It's got like 260 codes, but most people just use the top level categories, which there are 20. We've also had some divergence, I'll show this in a few more slides, between various dialects of Cameo. And so its complexity works against it. And what we've realized is we're coding a lot of stuff nobody's using, and if they are using it, it's probably not as reliable as we would like because it's so complex. So Patrick Grant last fall organized a workshop at NSF, or we had it at the NSF building, with some academics, government, private sector people, and we got together to try to design a alternative or a successor, really, to Cameo. And this is what became known as PLOVER, which is our new project. And PLOVER is basically going, we hope, will replace Cameo and get rid of some of the quirks. It's a somewhat different approach. It's still based in the same general framework that goes all the way back to Weiss, but PLOVER is our new effort. And so PLOVER is focusing on the Q categories. We combined a couple categories, dropped a couple categories. Didn't do that much. It's basically Cameo top level categories. We added something for criminal behavior, which wasn't in any of these previous ones. We're limiting the complexity of the sub-state actor codes, trying to systematize them. The other thing which I'll show you in a second is we're also trying to get a standard interchange format, because one of the problems with these various event data is they're all different, and they're also all tab delimited, so you don't know what's where. So we're shifting over to this thing called JSON, which is a Java-based data interchange format, and this should make it easier, much easier, to develop systematic, or to develop a set of tools that will work with all these data sets. We've also shifted from the massive hierarchical structure of Cameo to something we call events, modes, and contexts. And this is basically a what, how, why. I'll show you a couple examples. So again, we think this will both simplify the coding both for humans and for machines. And it's also a little more, it gets away from trying to have to juggle 260 different categories. It compartmentalizes things. So example of a mode in the coerce category, these are different ways you can coerce somebody. Even better example would be the assault mode. As I say on that previous slide, we combined all the modes of use of violence in Cameo, but we've kept the differentiation in the mode. So we basically simplified the top level category, but your detail comes in the other in the mode category. And then finally, the context is to try to provide why is something being done. So we've got quite a long list. It's actually a little bit longer than this now, to try to pull in things like is it military, economic, disease and disaster, which the IDEA framework had, and this is giving us information that isn't available in Cameo or WISE or some of the other ones. This is an example of the JSON. I'll show one, but most of these fields are optional. The point is, if you're going to have something, please label it this. And the other thing is JSON gets away this having to count which field you are in a tab delimited set. Okay. Skip over this. Mordecai, again, this is a geolocation system that was mostly developed by Andy Halterman. Again, it's on the open event data thing. And this is something you put into your pipeline. It runs in Docker, which is mostly an advantage. But basically, by running in Docker, you treat it as if you were communicating with a web page, even though it may be running locally in this particular example. There's lots of documentation on the site, but you basically hand it your story, and what you get back are a series of possible locations. In this particular one, it obviously picks up Tikrit. Baghdad must have been mentioned somewhere in parts of this that I dropped, but this is just from the website. But it's a way to basically hand the thing a story, and it gives you the information, mostly using geonames of what was in there. So I'm going to go through this. You can just go back and read this on your own. But basically, you should learn computer programming. And what is computer programming? It involves using loops and conditionals, data structures, and increasingly libraries, and then debugging. But really, learn computer programming. I've been trying to persuade people to do this for 40 years, usually unsuccessfully, but it's really important. Python has become kind of a standardized way of approaching this. It's, if you're going to invest in anything, Python, if not Python, then Java. And the main reason you're going to need these things, beyond my attempt to get you to write a coder, is this is where your pipeline and glue programs come from. And you can do these, I suppose, in R, but it would be really awkward. Whereas in Python or Java, it's really easy. And so you really need that. The other point is that you've only got a 1 out of 3 chance of getting a tenure track job. So this is a nice backup. And that's not why Jay Amini is a head data scientist at Google. He actually was looking for those jobs in the first place. But Google, it beats heck out of being an adjunct. Okay, end of rant. So event coding programs. I'm going to try to finish this up fairly quickly. We've got this batch, what's interesting is, despite the difference between all these programs, they generate very similar results. This is something I did in preparation for that, what became PLOVER workshop, is as you can eyeball this, most of that difference between accent, Petrarch 1 and Petrarch 2 is between the categories. It's not between the programs. I mean, there are some differences if you look at this real closely. For example, IQs pays more attention to violent events and less to this very ambiguous category in IQs that they more or less eliminate, or sorry, in Cameo, they more, but you know, most of the variance here, I mean, do your eyeballing analysis of variance here obviously is between the categories, not the coders. And the reason for this, I think, is simply it's in the nature of the news events. All these coders work pretty well. But so most of the variance is actually going to be in the events themselves. So you're not going to suddenly see a completely different world with a different coder. They're all producing pretty much the same sort of results, even though on a case-by-case basis, they seem to differ a lot. But once you start aggregating, they don't. Now, so my very last part is, so think you can write an event coder? Okay, well, let's see how complicated that is. It's been done as a dissertation. It's kind of a dissertation level project at the moment, but I would argue it's an MA thesis project. And the reason you might want to do this is the existing coders are very general. And there's a lot of stuff in a limited domain that are going to be a lot easier. And again, we've got these tools we didn't have in this particular case even 2 or 3 years ago that make this a lot easier. And so this, of course, Yoga. Is these things called universal dependency parsing, which are developed out of the Stanford project. And what these are is well, you'll see what they are, but they're done for all sorts of languages, I suppose. Ancient Greek, hey, you can event data code Thucydides, I bet, and make all your political theory people happy. But anyway, so a lot of stuff being done on this. That language list goes on and on and on and on. So I decided I wanted something that would work with universal dependencies and in PLOVER. And there's another project going on at UT Dallas on this, but wanted to get something, see how quickly I could do it. And it turned out very quickly. Basically, it was a weekend project to get a fully operational coder that works with real data. And it's not complete by any means, but the point is you're talking days, whereas without a universal dependencies, you'd be talking probably weeks. KEDS, Tabari, and Petrarch 1 took the better part of a month to get to the same point that Mudflat got to after 12 hours. This is output. This, again, is what a PLOVER looks like in an actual, this is actual story. And this is the input. This is the input coming out of Core NLP. Plus a little bit of the stuff at the top is some stuff I formatted to give the system just information, the date, and the ID. And the reason this is so, oh, and you can do cool visualization. There's tools out there to do cool visualizations. But the reason this is so easy is almost all the work's already been done for you in a dependency parse. So you basically, to code an event, you need to have a subject, a verb, an object, deal with compounds, and deal with conjunctions, and deal with agents. Well, here's the subject. It's nicely labeled there as in subject. It points to the verb. That's what the little 15 there points down to row 15, which is discussed as the verb. And it points to the object. Okay, most of the work's already been done. There are your actors that are available. They're right there for you. And then finally, in this particular case, we have a compound subject. So here's our conjunction that points to the actor. Almost everything you need to do is already there in the parse. It's just not that complicated. And this is what the coding looks like for that. That's a little too Python-esque, so this is what it looked like before I converted everything. But there's just a few little loops. This is not a complicated program at all. Now, again, by the time you read in dictionaries and all that, it's a little more complicated. But it's pretty darn simple. And as I say, the gist is all the stuff is already there for you. So that argues that Oh, yeah, well, I'll flip through this. In contrast, this is what the older parsing looked like, and here's what essentially the same code and just a fraction, much more complicated. Okay, so wrapping up, additional stuff that might be useful to do here. The Terrier corpus, you'll be able to submit your own code. There's intellectual property reasons you can't actually get access to the raw texts themselves, but be able to do customized coding on that. We could really use a common actor dictionary, and there's a bunch of sources like European Media Monitor, Wikipedia, and so forth for doing that. Really need gold standard records. The problem is they're really expensive to produce. Be nice if we can get some better, the NSF project is working on this rapid dictionary development. They're doing quite a bit of software development. Again, currently doing Spanish and Arabic, but like French and Chinese would be high priorities. We need a couple more mirrors of Phoenix so we're not dependent on the data provider, server provider we've got at the moment. Probably also need to change providers. These long time series are going to need to be calibrated because the news environment has changed dramatically. And we had to figure that out. Lots of things that I think could be done with near real-time data, specialized data sets, in particular for protest data. And then finally, there's still more work to be done on geolocation. So that's it, and I'm ready to take questions.
All right, thanks, Phil, for that presentation. At this point, Phil's available to take questions either from the live audience or from the remote audience. If you're in the remote audience, you can ask a question using the Zoom Q&A button that appears at the bottom of the webinar window, and I will keep an eye on that. But in the meantime, I'll open it to questions from the room. You should just feel free to go ahead and speak up.
Hey, Phil, it's Cliff.
Hi.
I guess one of the questions I had is when you were talking about some of this stuff getting extended back to 1945 and possibly even a lot farther, and you kind of came back to that a little bit at the end, because one of the things that has struck me fairly recently is how much language usage changes in fairly short periods of time, and you know, and that comes out in journalistic reports and all. And it strikes me that as you expand your categories of, you know, that things can fall into, that becomes even a bigger problem. And is that something that just you're not dealing with yet, that you're starting to think about dealing with, or that don't bother us, we've got bigger problems?
No, I think it's, again, we have never had data that goes electronically available stuff that goes back before the oldest time series. Our Levant time series goes back to '79, but that's it. And there's going to be a bunch of challenges. I think the Client Center, you have to defer to them, is going to initially just use the Petrarch. I'm not sure if they're using one or two Cameo dictionaries, but yeah, vocabulary changes. The actors totally dramatically change. And just, you know, we're picking up the period of decolonization in the 50s and 60s, and there's going to be a huge number of challenges. In terms of, we're actually contracting the categories. Plover really only has 19 major things compared to the 260 or whatever. And those modes and contexts are supposed to be general. So I think that will be less sensitive to the change in language over time. They're still, you know, like suicide bombings. Okay, suicide bombings were more or less invented by the Tamils in what I think the 1980s. But you know, you didn't have that as a major issue in the 1950s. Nobody thought about it. So that kind of stuff is going to take a lot of work. The other thing, Plover does drop the comment. Plover ignores comments, so you know, so you're not going to have to you know, worry about differences between Red China and People's Republic of China in terms of what is the affective content of that. But yeah, it's going to be a challenge. I think the bigger challenge is going to be the change in the elite sources like the New York Times drastically cutting back on their overseas coverage due to financial reasons starting about the 90s, and then these other sources coming in on the web. And I'm not sure, we're going to have to figure out how to do it. The people are working on this, but it's going to be an interesting challenge.
There's a kind of related question that came in from our internet audience. So Spencer Dorsey asks, love OEDA, the Open Events Data Alliance, or I think is right. But many of the media sources I've looked at put a restricted set of their stories into their RSS feeds. Why do you choose RSS over a page scraper?
I think it was easier to get that initially, but yeah, I mean, again, the problem with page scrapers, they're not that hard to work. I mean, you can scrape pages pretty easy. It was, we were trying to get it done and trying to get it working. But yeah, you could, again, that's a nice thing. Want to try that? That'd be great. Okay, the code's up there. I did a page scraping exercise for the Good Judgment Project a number of years, about 3 years ago, there's a facility in Python called Goose that strips out text out of HTML, and it was, I got about 2/3 of it. I got useful stuff out of about 2/3. So again, it's way easier than it once was. But we started with the RSS feeds just because those are more user-friendly, as it were.
He apparently has tons of code to share if you're interested.
Excuse me?
He apparently has tons of code to share if you're interested.
Yeah.
So Phil, what about the next step forward in instead of text-based, language-based, that is oral information and the ability to capture, process, and digest it? Or it's non-text-based, where it hasn't been translated to text?
Yeah, that's way beyond what we're doing. Yeah. Once you, I mean, there's a huge, lots and lots of people are doing that kind of thing, and some of them can even talk about it. But the difference, if you've ever looked at the difference, well, if you've ever looked at a transcript of your own speaking, the grammatical structure or lack thereof of spoken text versus written text it's a huge challenge. But yeah, we're not trying to do that. We've completely got our hands full on the textual side, just because there is so much stuff out there. And again, we're not getting it all by any means, nor is ICEWS.
So Alistair Windsor asks, do you think there is value in parsing the stories for affect signals such as anger or anxiety?
It's a different, that's really a different literature. There's a very large literature on that. And one of the things, again, in event data, what we've been trying to do, granting the usual caveat that we're only coding what is available. We don't pretend this is a God's eye view and it's got all sorts of biases that in terms of coverage, but we're trying to do stuff that is happening, stuff that you can stub your toe on, so to speak. And that's particularly true in PLOVER, because we dropped the comments. There is some affect in here, so there's a distinction between disagreements, threats, blah, blah. There's actually quite a bit, actually, when you think of it. But we aren't trying to do the close parsing, for example, of a statement by a foreign secretary or ambassador. Okay, is this really, is it really positive? Are they just saying it in a positive way, but they've really told you that, they don't like you at all? That kind of stuff we're not doing. There is definitely a literature on that in computational. It's not so much linguistics as natural language processing, rather large literature. In fact, the very first automated text processing system in the social sciences, thing called General Inquirer, that goes, I think, back to the 60s or at least 70s, that was what it was doing. But we haven't been trying to. And in fact, in the case of PLOVER, as I say, we dropped that. In Cameo, there are different categories for positive and negative comments, but the system's not sophisticated enough to pick that up with any reliability, so we dropped it in PLOVER.
Tom Pike asks, I'm looking at the social network evolution of substate groups to form emerging power clusters, for example, the Libyan Civil War. The basic familiarity with IQ's GDELT, are we still allowed to say GDELT? And news in general is that these groups are still below the threshold of reporting. So IQs would classify source, rebel group, target, government versus source, tribe X, target, government. Do you think this assessment is accurate, or am I missing something?
No, it's definitely accurate. And this is the point where even if you don't want to write your own coder, you might want to definitely write your own. So let's just say you're looking at South Sudan. Well, that's got terrible coverage, but let's take it anyway. Let's say you're looking at, or Central Africa more generally. These are lots and lots of small groups that are below the radar on IQs. But most of them have distinctive names, or at least they do for a while. And if you've got a source, say you're coding NGO reports, and as long as they're using those names, or you can obviously put synonyms as well, that's the place where you could take your own, you could take your pick. You can use, I think I mentioned Accent now can be licensed. Any of these coders, whichever one you decide you're happy with, and then add those in to your own dictionary. All the dictionaries are open source. Both ours and also the IQ's dictionaries are open source. Or I don't know if they're technically open source, but you can get a hold of them. And so you add those things in and with your own codes, and then you can pick them up. Yeah, but yeah, I think the BBN folks just recently expanded their dictionaries using Wikipedia and DBpedia. I don't know if that's going to be released as part of IQ's. I think it was for a different project. But if you're, as I say, I think the problem with a lot of these data sets are they're too general. Okay, so IQ's is trying to cover the whole world. Phoenix is trying to cover the whole world. Whereas typically, even where we got started with this stuff way back in the 90s with KEDS, the KEDS programs, we were just looking at the Middle East. We were just looking at 6 countries in the Middle East. Well, we could get much more detailed dictionaries there. And so you could get these little Lebanese and Palestinian factions and all the Israeli political parties that change every election, stuff like that. That's all built into the dictionary. And these systems are all designed to put that very specific stuff in that's, as you say, is going to be below the radar for a general thing. But if you're looking at the Middle East or Central Africa or Central America or whatever, you can put that information in. It's going to not take you that long. I mean, you're talking, you're probably, well, it depends on the area, but you're talking days of work. You're certainly not talking weeks. And then you can get your own customized data set.
I'm interested in asking a slightly more general question. I teach most of the methods classes, or not many of the methods classes here at Rice. I can tell you've worked for the government because you went through about 50 acronyms during that talk.
Oh, yeah, sorry about that.
Well, that's a danger of becoming associated with the government. It made me think about if I'm a first year student, what am I supposed to be doing? And you mentioned, getting to know programming in Python. I kind of wonder. I feel like it might be a mistake to tell a student, oh, just do everything, right? And then something will work out 5 years down the line. I feel like maybe there are sort of different approaches to sort of studying international relations or whatever you're studying, and you kind of need to decide on what general approach you're going to take. And so I was wondering if you have some thoughts on how your approach fits into the sort of I know you're out of academia now, but the sort of academic study of this, and where there's some synergies and where there's some sort of conflicts in sort of picking an approach to studying for example, studying international conflict?
Yeah, so my approach, and again, it's not just me, it's the event data community, has always really been focused on forecasting. And so that's a fairly small niche in quantitative IR in international relations. So it's not that small of a niche, and it's a lot less small than it once was. But yeah, I'm interested in conflict. I'm really, I mean, quite a few years ago, I realized I'm really not an IR person. I'm a conflict person. So I am as much in the comparative politics literature as I am in the IR. In fact, if anything, I'm more in the comparative politics stuff now, even though I was technically IR. And yeah, so, and yeah, you can't learn, the first year in graduate school is always overwhelming. And there's going to be, 20 people saying you have to learn everything I know. Except up to date, and so you got to pick and choose. But I think to the extent it's still useful to pick up some general tools. And I guess the argument I've constantly made on programming is I think people spend a lot of time learning a little bit of math that they're frankly never really going to use, because you can't learn just a little bit of math. Whereas if you learn a little bit of programming, you can use it immediately. And but as I said, I've been making that argument for 40 years unsuccessfully. But I think people go out and do it anyway. They kind of sneak out behind, like the woman in the movie Hidden Figures who steals the Fortran book from the library. That's what you need to do, is don't steal it. But I mean, she had reason. Couldn't check it out. It's black, but yeah, sneak in. Have the Pythons. Watch a learn Python online course. While you're supposed to be reading Ken Waltz or something like that. Yeah.
So Leah Windsor asked from the internet, given or granted that event data is noisy, it's not noisy at random. For example, in IQs, there's an annual spike in nuclear events in early August, which is the anniversary of Hiroshima and Nagasaki. And in political assassinations, attempts are reported even if they are never successfully completed. IQs includes them because event counts factor into issue importance. What do you believe? What are your reflections on these patterns, their broader significance, and how we should deal with them?
Yeah, and this is where we just need to have, guess what, folks? It's big data. It's messy. That's how the world looks, and we need to do more experiments than we've done with how to filter this stuff out. Sometimes really simple stuff really works nicely, like those global tension graphs that I showed you. That was an 8-hour project, and it turned out that what I thought would works pretty well. In other cases, the noise completely, swamps things. For example, things like, if you get these periodic things that pop up, but it's just a source of, it's due to the news coverage. Yeah, just filter them out, or just take them out, or whatever. Once they're there, you can filter them out. Moving averages help a lot. Those are noisy series, but you start doing moving averages on them, or the low S, or whatever your favorite smoothing algorithm is. It takes a lot of the noise out. It's like any data issue. You just need to get familiar with the data, see get characteristics of the data generating process, as Aaron Simpson would tell us constantly. And we know that, journalists run in herds. We know that basically journalism follows the money. So if there's not money involved, like in Central Africa, you're going to get lousy coverage. If there is, like in the Gulf, Persian Gulf, you're going to get a lot of coverage. And you just need to kind of adjust this stuff. Some of this calibration can be done automatically. In other cases, it probably just a case of saying, we took this out because we knew X, some of the examples in IQs. Yeah.
All right, well, that's all the time we have for this week's IMC. I want to thank Phil Schrodt for being our presenter this week. His presentation will be posted to our website shortly after this broadcast if you'd like to share the presentation or watch again later. I also want to announce this is the last IMT talk for spring 2017. I'd like to thank all our presenters and viewers for being a part of the IMC this semester. If you're interested in giving a talk in the IMC in the coming academic year, 2017-2018, please contact me at justin@justnessery.com, or you can see our website, www.methods-colloquium.com. Phil, thanks for your presentation today.
Thank you for the opportunity.
Yep, and thanks everyone for coming, and hope to see everyone next year.